Okay, my friends, once again, prepare for a shocker du jour. We're going to be talking about the University of Arizona and the Bennu samples that they brought back and my claims that there is nothing but biology. And I also claim that at least some of them out there understand that, but they are not allowed to speak. Okay, my friends, this is going to be an exciting time because we're going to be talking about this asteroid right here, which is called Bennu. And what they found is this sample right here when they brought it back to Earth from what they picked up out there. And what that sample is in relation to biology, which I claim there is nothing but biology, and it can be enormously huge biology, but it is still biology. And I claim that this heart muscle from a heart attack victim here on Earth is the same biologically as what they brought back from Bennu, which is a heart, and its heart muscle is all it is just one big giant muscle. That's it. And that's what they brought back, is a little piece of it. It has layers of membranes, a membrane, sarcomeres, a membrane, more sarcomeres. This is the phosphate layer, which is phospholipids, which is the membranes. These are the sarcomeres, which are the little blocks that pull in and out. That is a muscle, so is that. And that came from a heart, which is there. And that heart is the same as psyche, which is here, because these are the valves. And this breaks right off here because of iron banding. There's a red and a blue tube going straight around the heart, and you snap it and they pop right off. Right down to the valves, you get right down to there. Well known, well understood, and they end up with this. And that's psyche, that's a monster. This one here is the same thing. This is a valve. That's a valve. And his big one right here is a valve. You see it? And this is all covered with blood, basically. When they blew the stuff away, they went way down inside. They didn't realize, they thought it was going to be solid. It just dusted away like popcorn, they said, which is, it's basically blood cells. And then they hit the muscle and popped and grabbed a chunk of muscle and headed back to town here. Now, so these are the people that are doing the work on it. Is University of Arizona, basically, is a big one in this. And this is, we spent a lot of money on this, and this is the asteroid Bennu, and how can we better understand? Well, let's look at it a little more carefully, I would suspect, and get a biologist, an anatomist, a chemist, and all of the people that understand anatomy and so forth. Now, I just got off the phone, off the line here with Pierre Brunet, who is an expert in astrophysics. And I'll let him explain for what he does himself, or I'll just tell you, he's gone to a number of schools for astrobiology. And one of them was the University of Arizona. And they told him that he was right, presenting what he presented, which was, I was dealing with him years and years ago, almost 15 years ago. And he presented that to the professors, and they said, yeah, you're right, but we can't teach that because we'll lose our jobs. That's what he said. That's what they told him. And I've heard that from other ones too. They said, I'd love to be able to talk about this, but there's just no way I can. And there isn't. They're right. I understand that. Self-preservation, you can't, I don't have anything to lose from this other than just people think I'm an idiot. And you'd be surprised at the reactions. Some of them are very, very angry sounding. Anyway, and Pierre has nothing to lose now either, because he's retired. And the only people I've heard from that are willing to talk are the retired people. Jim Boland's another guy who was with the Army Corps of Engineers. He certifies bridges and water supplies and this and that. And they had water remediation problems that he had worked on. And they apparently couldn't figure out why the water would show up somewhere way distant from where it had soaked into the ground. Well, they don't just soak into the ground. They get into the tubes of biology. that run throughout the ground. Membranes. It's a heart. That's a lung. This is somewhere, I don't know where it is. These things are all over the earth. And they're biology, just like that's a piece of biology. It's a shoulder, I think. And there's the tendon coming down from it right here. And there's the muscle that follows. This is blood. You have to understand what you're looking at through mud fossil eyes, and you can fully see it. This is nothing more than that. It's just what it is. And these are hearts. Just as this is. And look at this. These are tubes. That's a tube. That's a tube. You see? These are valves. That's a tendon. These are the colors of blood. The 3 different states of blood. The red, the yellow, and the black. This is from a heart, and it's gigantic, and these things are everywhere. Now, Pierre has agreed to discuss his understanding of what he learned in all this time from all these different courses about astrobiology, how these formations occurred, where these minerals and metals came from, what these craters are, and what these tubes are sticking out. I'd like to have some explanations. Now, I'm not going after Pierre because I believe he understands. He said he presented all this stuff to the University of Arizona, to the professors, and they, at least one of them agreed with him, got an email back from him saying, "You're right, I'm sorry, there's nothing I can do, I can't talk about this." And I've had the same thing happen to me too, and I've tried to contact virtually everybody. I've been doing this 15 years of being extremely vocal, and you just can't get through that wall. So anyway, as far as I'm concerned, he's a world-leading expert in astrobiology, as I am. All right, and he ain't bragging if it's true. And we're going to discuss it, talking about mainstream, which he has learned in extreme detail. I have too. I don't just take my side of it and say, "Oh, I can dismiss everything they say." No, I say, "Well, what do you say?" And they say, "Oh, it all happened from a Big Bang." I say, "Well, from a Big Bang, where did Big Bang come from?" Well, that doesn't matter. Nobody knows where it came from. I agree with that, but what I see after material evidence is some form of intelligence guiding this. This is not just slime, accidental bumping of molecules into each other. That is absolute insanity. Something is going on here that is extremely deep. And you don't have to sign off to that if you don't want to. But that's the way I'm seeing it. And I'm a material scientist. I do material evidence and chemistry, anatomy, physics, all of that stuff. And if you don't do any of that stuff, you don't do it all. You have to do it all. You do it all, you do nothing. Because once I hit you with a question, if you hit me with a question, I will give you an answer. It may not be this instant. More than likely it will be. But if it's not this instant, I will give you an answer to that question. All right? You have to accept the reality when you get the answer, though. All right? When you see this, and it's muscle, and it's got DNA and RNA and uracil and 16,000 organic chemicals, and it has all of these layering and these phosphate layers, and it has sarcomeres, which are these little red blocky things, and it's a heart from a heart, and you see this, and it has the phosphate layers, it has the sarcomeres, it has the layers, it has RNA, DNA, uracil, 16,000 organic molecules. It has muscle bundles here cut this way, and these are sarcomeres showing them in their, that way. So you have to be able to accept the answers that you get. And when you see what this is, and what this is, and what a heart is, when you strip the plumbing off the top and it breaks right along that line, right along that line. It's called iron banding. You see the two different colors? It's iron banding. There's a blue and a red vein and artery that run right around there. When you die, and it starts to harden up, you tap it and they just pop right apart. Because the red pushes the black away. And I have many cases of that. And autopsy guys tell me that happens when they start to do, working on cadavers to see the anatomy, and they cut them open and the heart just falls apart. Because even when, as long as they stay if the blood is moving, they're okay. But if that blood stops, I don't know how long it has to stop for, but it may only have to stop for a short time to make that pop apart. Because they don't like each other. It's polarity, and polarity works pretty damn fast. If they're going past each other, it's okay. Everything's moving. Boom, 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 boom. That's how your heart works. Boom, 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 boom. If it stops, at some point it's going to go and pop right apart, or it's going to push. That could create a weakness in the heart. Who knows? All right, I am doing the rest of this video for Pierre because he hasn't seen a lot of the things. We had crossed paths years and years ago, probably close to 15 years ago. And I believe that's when he was presenting this same sort of stuff to the University of Arizona, and they said they wouldn't speak about it because they would get fired. That's what he said. Now, I'll let him make that statement himself as if it's true or not, but that's what he said. And they know that this stuff is biological, but they can't speak about it. Now, University of Arizona is the one that's doing this examination of Bennu, and how can we better understand? Well, Pierre and I are going to go through this. This is a heart. It's a heart. That's heart sarcomeres. These are heart sarcomeres right here. These layers are the membranes, one layer after another, and the sarcomeres are in between. That's a bundle of muscle. The heart is nothing but a big bundle, a tangle of muscle, and it just goes loop, 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 loop. It's like one long band that wraps in and out, and it pushes in and sucks the other one out. Something like that. I know that's not technical, but it's primarily correct. This is what they came back with, and they've been looking at this for almost 2 years now. I never expected they would come back with muscle. I expected them to come back with blood, but when they hit, they pushed all the stuff out of the way, and it was just like they called popcorn. They went down way inside and scoop, and grabbed it and came back. Muscle, my friends. And it has every biological bit and piece that is in a human heart. All the same chemistry, all the same DNA, all the same RNA, same uracil, same organic compounds, 16,000 of them. Apparently they say it must have come from some wet, salty lake that got hit by something. No, this is a heart. That's a heart. And any anatomist or any heart surgeon look at this will understand that is a heart, which is psyche, gigantic. That's a heart. And these are the heart valves. There's like a whole batch of blood cells on top and little debris and so forth, minerals. But it's just dust basically on top of a heart, which is just like this. And they snap right there at the blood vessels, where the red and the black. Well, black is in the mud fossils. Red and blue, the vein blood they show as blue. It's black when you get into the mud fossils. You have the red and you have the black. And they oppose each other. And they snap right along, just a snap just like that. And that's how the top plumbing pops right off of these hearts. So I'm going to show all this stuff about meteorites, because every one of them is a body part. Everything on Earth is a body part. Everything that was stated in the ancient texts, I believe, is pretty accurate. And I'm going to show you what Chat says about what I'm saying. I'm not hiding this from anybody. I've been saying this for many years now. All right, this is Chat. This is not correct, but it's close. Roger Spur's claims in summary. Asteroid Psyche. Spur claims Psyche, a large metallic asteroid being investigated by NASA, is a giant fossilized heart. Yes, it is. He points to the surface structures, layering, vein-like patterns, evidence of biological tissues, including chambers, valves, and arterial branching. Yes, I do. Now this asteroid Bennu, it's Bennu. I don't know how they got that. Likely referring to Vesta. No, I'm talking about Bennu. And I've shown you, and you will see a Bennu is extremely obvious. It's a heart. So it says like, Spur claims that asteroid Psyche and asteroid Vesta, which I don't know about that, well, they're all fossilized something. But asteroid Psyche is absolutely 100% a heart, and so is Bennu. The heart's other organs from ancient, possibly interstellar life forms. This is part of his broader mud fossil theory, not accepted by mainstream science, but it forms the core of his independent research. Yes, it's independent. Would you like a breakdown? No, I think I have it. Thank you. Okay, this, like I say, was primarily for Pierre so he can get up to speed of what I'm explaining and showing here, in case he hasn't seen it yet, and I don't think he has. So we're going to be talking about all of this stuff, and he's the guy. I mean, he's taken courses, and he told me that he had a 2-inch thick file of handwritten pages about astrophysics, I think from one course. And he's taken them in multiple places. He took 15 different courses through Coursera. I did too. I took them all over the place. And that's why I'm always saying I took a course here, I took a course here. Coursera didn't cost you anything. It was free. And but you don't get a piece of paper. Who cares about the piece of paper if you just want to learn something, or you want to at least engage? And that's what I did. And I engaged with a lot of different universities, and I came up with the same result every time. They would say, I can't talk about that because either I don't know, I'm not an expert in that, you have to talk to somebody else. It went on and on and on, excuses. But occasionally they would say, I can't dispute it, but I can't talk about it. And that's what happened to Pierre at the University of Arizona. So, and it happened to me too at a lot of places. They sort of hinted around, but they, you know, like they just, I don't want to see it. I will not look at it. Don't show it to me. Because they know at that point they're sort of, you know, they're obliged to engage, but they should be obliged to engage anyway. If they're out teaching the kids, this is what you have to believe to be educated. These are universities. These aren't just, you know, kids hanging around a block making up stories. These are supposedly places that investigate and do the research and do their fiduciary duty, which is a legal obligation to the students to act in their best interest. And I don't see that, and I have not seen that one little tiny bit. So I'm going to engage with Pierre, and this is going to be absolutely fascinating because he, as far as I'm concerned, is a world-renowned investigator into astrobiology. You don't have to have that piece of paper that says I paid you $30,000 to give me that piece of paper when you get it for free. And he was able to engage with the professors, and they said, yeah, you're right, too bad. Nobody really cares. They're PhDs. Perfectly happy deluded. Okay, get ready, because here it comes. I posted on this site here, which I'm not allowed to post basically anywhere. Any geology, any of this, any minerals, anything about earth sciences and so forth, they just won't let me. But here, they're looking for the things that people won't allow to be spoken of. Ancient giant trees, oddities, aliens, conspiracies, giants, and the insane. Well, all of my stuff is insane. I do not disagree with that. Absolutely. Giants, absolutely. Oddities, absolutely. All kinds of crazy things. And I do address the giant trees. However, they did dissolve primarily in the Great Flood, whereas flesh did not. It cooked. And it cooked because of being boiled. And these are membranes. And that is the membrane in us. You could look through that, basically. This is 6 feet thick from top to bottom. There's 2 layers in the membranes. They call them a bilipid. And these are all membranes. And there's so many membranes, as you can see in here. It's the same stuff. You know, it's not that big, but it's the same basic thing. It's just, if it had more transition metals, where this was a heart or lungs or liver, right in that area you'd have a lot of the blood metals. Those are all blood metals. They usually do studies of about 26 metals in the blood. Anyway, Pierre Brunet posted that he's doing a bioastrology course with the University of Arizona, and he showed this proof to the teacher, and the teacher said he was right, but he couldn't say it or teach it because he would lose his position and his job. So I contacted Pierre, and he's agreed, because he's not only taking it here, 2-inch thick ream of notes and things that he had to address. Okay, my friends, sorry about that interruption, but this is Pierre Brunet. He was taking the University of Arizona, and the guy said he can't talk about it, but in other words, he's admitting they're wrong, but they will not discuss what's right. That's not the way to teach. Teaching is science. Let's engage. Let's have an open discussion. There's a new way of looking at things. If we're scientists, we look at them. If we're not scientists, we do what academics do, is they don't address it. Here there's like a lot of posts in here, a bunch of baloney created, keep the inner child dreaming. This is the kind of people that are PhDs, perfectly happy, deluded. And, it's time to stop this, really, because I thought it would change with all of the evidence. Evidence has no place in academia. Okay, my friends, as you will see, meteorites are not understood, and that is an iron or metal meteorite. I don't think anybody would argue with that. What would I want to argue about is with this, and it's not an argument, it's what is it? What's that red spot? What's this black spot? What's going on down here? Why is it red on the edge here and black down here on the edge there? And why is it so brilliantly red here? And that is brilliant, brilliant red. Brilliant red. Why? Well, I can tell you why. Let's get started. Hello, my outstanding friends. Shocker du jour, supreme, deluxe, over the top. We're going to be talking about meteorites. And they are broadly classified as stony, or iron, or some of each stony iron. Now, the stony iron, they claim are the rarest. Well, I have a whole selection of them here. I have all of the different types right here. And I think I have other ones that they don't even know about. So let's see. I put out a video the other day asking for help from an expert about my meteorites, and I didn't get any responses. So we're just going to have to make our own claims. And you tell me if I'm wrong, or you tell me if I'm right. And if there's an expert out there, I would certainly like to engage. That's what I try to do, is work with experts, and they basically have refused. Because the things that I present are very, very hard to dismiss. And you're not going to be able to dismiss this unless you can give me an explanation. And I'm certainly willing to listen. Okay, there's a little iron meteorite, the same as this one here. You see all the little pock marks in it. And it's basically, it's all metals, and primarily iron, and I can tell you why in a minute, but I'm going to make some statements. I'm going to show you an iron meteorite cut in half, and some outrageous statements, and then I'm going to support them with factual evidence. Okay, my friends, we're doing meteorites today, and they are on the table right here, and I have every type of meteorite there is: the stony, the iron, the stony iron, and I also have other ones, or at least one other one that I don't think anybody's ever seen before. I'll show you that. And what is this, and what is that? Let's look at that very carefully. Of course, you understand, this is a little iron meteorite. All right, and you see them all the time. They have all these little holes in them. It's iron. It's metals, this is metals too. It's not just iron. All the metals, when you smelt something that has, it's biology. This is a lung. I'm just going to tell you right now, and these are blood vessels. That is a vein, black, and that is an artery, red. And they came right up the side, I can tell, because up in here, there's red right in this wrinkle coming up. That was where the artery ran all the way up to the top. And this tip tells me, I believe, this is a digital terminus, which means it's the end of a finger or a toe. And the red comes down and it comes over to the vein, and the vein brings it back. Now let's look at this in its entirety. But don't forget, this is an iron meteorite that came through space. Nobody is going to deny that. Nobody can deny that. It came through space and it has blood in it, and nobody can deny that either. And I can almost guarantee you they could do some form of a test to prove that that is blood. They say, oh, that's just iron oxide, and that's just iron oxide. Well, why? Why is it in the middle of a burnt up, I believe, digital terminus? Okay, my friends, I'm about to make some outrageous but true statements. This is blood, the red blood, and this would be where the iron blood came through, filled in with silicates. These are what's called chondrules, and guess what this is? This is a meteorite, and it's called the oldest solid material in the solar system. Is this mass right here? These are all chondrules. They're little balls. Now let me show you what this really is, and it's biology. I have make absolute 100% proof of my statements. And we have biology right here on Earth that came from asteroid Bennu and is not being examined correctly. Let me explain. Now I have all the different types of meteorites here, the stony, the chondrule, all of them. But as I just showed you this one here, this would be considered a stony meteorite with all these chondrules on it. And I will explain to you what those chondrules are. Then you get into the iron meteorites like this. Now this is cut across. It's an iron meteorite. Something like this would have started out as an iron meteorite, and they just cut across it, and inside is all these metals that have coagulated, flocculated together. Now, the bigger the item is, the more it will smelt, and the more it will, you won't even see these. Like this started out probably with all these little holes like that. But as it just melted, it just came in. The more it melts, the more it just comes together. Now, what is this doing here, and what is that doing there in the middle of this iron meteorite? Let me show you what they are, close up and personal. Well, that is close up and personal. here's from a distance. All right, this is the whole thing. Well, what is it? Well, it's just a bunch of iron, a bunch of metals. Why? What about this wrinkly looking thing? And what about this wrinkly thing? Why is this one red and why is that one black? You see this one here? If you look really close, you can see there's red in there. You see that? And this over here is just brilliant red coming in. Now, we as mud fossil people know red and black means vein and artery. And that is the artery side, and this is the vein side. Now, I got a feeling this could be like at the tip of a finger or something, because that's how it comes through. The black blood is on one side, the vein, and the red blood is on the other side. And they just snap right off where they attach. Now, I can't make any determination like that. It's just too melted. But fingers and toes, hearts, livers, lungs, saturated with blood. Saturated with blood. There's so much blood in your fingertips you just can't imagine. And if a creature dies with their fingers down and the blood seeps down into their fingers, it becomes almost 100% blood. And that could have been just what that is. Or it went flopping through space and the blood just centrifuged out into the, which they call a distal, furthest distance away from the heart, which would be the end of the fingertip, which would be right here. Now, I have a fingertip right here. It was completely eroded away. And you see this? This would be basically right at the very, very, very end of the tip. That's the what they call the apical tuft. This could be, because the rest of the fingertip would come back to here. And I got so much stuff, it's overwhelming. But my point is, there is blood in this because it was a body part. I don't know what it was. I've made of all kind of determinations about it, but I don't have enough evidence. I need to see what's this going on here. And I need to see what's here, and on the other side, what, like I have this one here. I don't know what this is. I really got to be honest with you. I have no idea, but I think it's some kind of an organ, but I don't see any specific structure in here. But I do see it's just all cooked off, as you can see, all around, coming through the atmosphere, and it's got the scale all around. I wouldn't look at it in a microscope. And it's cooked. I really got to look at this close, because there's a couple of there's that one seam here, but I don't see much of anything else in there. I'd say that's got to be an organ. Any rate, there's a little bit iron. This is stony iron. Stony iron means it's not iron enough to be really magnetic like this one here. This was a lung. Lungs are just saturated with iron because it's blood, and it boils off and turns into iron. I'm telling you, we're living in a world that nobody ever expected. It's just, and it's hard for people to accept. It's hard for them to even consider. That's the problem. That's the real problem. They have to consider it and they have to address it. I'm showing evidence. It's undeniable. That is not deniable. That's in our hands, and Bennu is in our hands, retrieved from asteroid Bennu, a mission out there. They brought it back, and it's heart sarcomeres, phosphate layers, which are the membranes. It's 100% the biology of heart, and it has all the DNA, the uracil, the RNA, everything. And it's so much for the human mind to even address that it's been sitting around for almost 2 years now. And they just haven't considered the obvious. All right, my friends, this is a selection of meteorites, and this is a selection of meteorites. We're going to be looking at it in a microscope. I have the iron, I have the stony, I have the iron stony, and I have one that I don't think anybody's ever seen before, which I will show you, which I'm going to call a bony. And I'm going to call all of this stuff 100% of the things in space are biological. This, I am going to show you in 1 second, has blood in it, red blood, and vein blood, artery and vein. And it comes right down the side. The black runs right out the side here, which is, I understand this, and then it also runs the red and the black in the center, and the red is on this other side and runs down the side of what I think I know what this is. And I'm going to explain to you in a minute. It's off the charts crazy. Not my fault. It's what it is. Don't forget, you got vein blood here, and there's your terminus. You've got artery blood here, and there's your terminus. You've got vein and artery blood here. Let's look at what a fingertip looks like, because I'm telling you right now, I believe that's a fingertip. Before we see the fingertip, it's 100% for certain that's red blood. Was red, whatever it is, and for some reason it runs right down the side here, all the way to the end, which I don't have here. I just got this big shot, and this is the black part, and that runs over to the side too, which I just showed you a second ago. So those two are just undisputably black and red, and here's where the red runs to this, which sort of broke off semi-evenly, and then there's red and black here too, Y, and then there's the black here. So red, black. The black runs up to its terminus, the red is the tip, the terminus, running back towards the heart. So this would be, they would call this the distal end of a fingertip. See, this is the end of a fingertip. You got two spots here, which are, let's say, from the artery, and it comes to its terminus at the end. And then you have the two spots here, which I showed you back on that other one, and two on the side. They come in from the bottom, heavy duty. Well, the artery comes in, the vein comes back. Right? That's why one of them's red and one of them's black. And then in the center, you have those two little spots that show up, just a little tiny spots. Those are the little feeders for the center ones, which I think I showed you somewhere here. Yeah, right here. Don't forget, there's the red blood coming in. It filters its way over in a living thing, and then it ends up getting into the vein, and the vein brings it back up to the heart to be pumped. This is also bringing blood in, the red side, and some vein blood going back. That's the nature of blood. It comes in, it goes back. But this is the tips of your fingers and the tips of your toes. I refer to them as the digital terminus, and there is a ton of blood there. That's where all your blood goes. It ends up going there. That's where all it ends up, and then it comes back. And there is no question in my mind, and I know this can be tested, and I have these meteorites right here, and I know this one here. Well, there's a couple of them that, well, I know there's absolutely no question there's something we could find in here that would be better than this quality. This was heated up so much that it completely turned into a ball of metals. This was so small that it's heated enough to cause stony iron. This is a stony iron, only it's more iron than it is stony. And I'm sure there's, well, obviously there's a spectrum, because it's the stony turning into metal by burning off all the stony stuff. So it didn't burn off enough of all of the stony stuff. There's still some good stony stuff here. And I'll show you. Where do you see this tip in the microscope? And all these are alveoli that explode coming through space as it heats up, because they're little bags of blood, and they just pop. And when you see it in the microscope, you can't miss it. You can see the blood, you can see the fibers, you can see the pleura, you can see the latch right there that latches that lung into the body of whatever it was in. And it was in some kind of little chipmunk or something. I have no idea. And then I have other ones that, I got all kinds of stuff here. This one is intriguing. All right, you see that? Wait till I show you this thing. This is intriguing, my friends. Now, and then of course I have this one, which is even more intriguing, and which came through space. This is a complete stony. That's a stony, which is that. And then of course I showed you the iron, which is basically an iron. Well, this is iron stony. I don't really have any real solid iron ones like that. No, I don't have that. Mine are too small. Now, I'm not making these claims offhandedly. I've been doing this for many years, and I've been quite vocal about it. And I asked chat, what is my opinion on matter? And it said, Roger Spur of Mudfossil University platform claims that much of what we observe in space, including asteroids, meteorites, planets, even comets, are biological in origin. His theory proposes that many or even all cosmic bodies, and I say all, are fossilized remains of biological life forms. Some of them are not even fossilized. They're still pretty wet. There was a Kentucky meat shower in, I think it was 1876, and the meat came all over this woman's property. One guy ate some of it. He said it tasted like elk. All right, so I say biological, they're life forms, including tissues, organs, cellular structures, have been preserved on a gigantic scale. Yes, chat, exactly correct. Well, what else? Key points of Roger Spur's claims. Mud fossils on Earth. He first proposed that rocks and mountains on Earth are fossilized soft tissues of once living creatures, including lungs, tendons, blood vessels, even entire body parts. Biological meteorites and asteroids. Spur has extended this idea to space objects, claiming many meteorites, not many, all, are fossilized biological materials like organs or muscle. Surface textures and internal compositions of asteroids resemble biological tissue and blood. They don't resemble, they are. Cratering, coloration, and mineral content support this interpretation according to his analysis. No, according to reality. Everything is biological. That's my statement. That's exactly correct. He has suggested that all matter, or nearly all, not all, is ultimately derived from biological processes, including planets, moons, possibly even stars. Yes. Space is full of organic matter, no question whatsoever. He points to the presence of carbon, amino acids, complex molecules, DNA, RNA, uracil, 16,000 biological chemicals, sarcomeres, phosphate layers of membranes in Bennu, taken from space back to Earth. I point to them because they're there. I'd like to have somebody discuss it. So I point to the presence of all of these things, amino acids, the building blocks of life, DNA, RNA, uracil, all of that, and complex molecules in comets and asteroids as Bennu, they just brought back to Earth. Space dust as evidence biology is universal, not just earthbound. No, it's all over Mars, it's everywhere. Is this mainstream science? Hell no. These views are not supported by mainstream geology, astronomy, or biology. Yes, they are, if they would look at them. Why? No peer review evidence, because they won't peer review it. I show the evidence. The evidence is there. It's the peer review that's not there. All right. Standard science holds meteorites and asteroids, primordial rock and metal. From where? From where? Formed from non-biological processes in the early solar system, from a big bang. Organic molecules can form abiotically in space. Yeah, why? How does that happen? But this doesn't make the entire object biological or fossilized life. There is no peer review. That's the key. These are my claims, 100% biology, and I'm going to show you. If you can deny it, deny it. I'd like to have some expert deny it and discuss it and have an interview with me, and we can discuss it back and forth. I'll be respectful, but I can show the evidence to support my side of the claims, and I don't think there's any evidence to support theirs. But they might have some. I know that the minerals and the metals are there. There's no question about that, but the biology's there too, and the biology creates the minerals and metals. Metals are in blood. All right, this talks about 26 metals is a common number used in the study, and it's not an absolute number. It can be much higher than that, and it's all these metals, basically, and a bunch of other minerals, all kinds of stuff in the blood, in the serum, and in the plasma. There are 3 different states of the blood, and I looked into all 3 to see what the difference is in the metal concentrations in these different states of the blood. Very interesting study. It was on, I think there's 106 healthy people, and they did all 3 states of their blood to see what the variations were. Very interesting study. You got a lot of work to look into that. But that's what's in your body, and that is what they call them transition metals, because they transition things through your body. They bring them over, drop them off, and go back and get recharged. It's a polar thing. It's all about polar stuff. And this is all about studies measuring metals in blood. So I'm telling you, blood smelts into the metals. Basically, it's the blood that's giving the metals into these meteorites that are being smelted coming through space. And you got to get hot. Well, hold on. All right, I just showed you there's like a bazillion metals in blood, and these are the melting points and the smelting points of different metals. These are metals, so they're in the blood. We know that. There's just no question about it. This is a little iron meteorite, and it's a lung, and there is no question about that, as I will show you in the microscope. And it's iron, but it's not 100% iron. So instead, it's its temperature that it must have reached would have probably been about 2700 degrees, 2750, maybe 2800 on the low end. So it still had some nickel, and it wasn't entirely iron. All right, so when you get up to the extreme temperatures, way up, it just melts everything into a little ball of iron. The hotter you get, the more pure the iron becomes. It just gets rid of all the other stuff, and iron remains. All the other stuff burns off at lower temperatures. You see, you can get iron-nickel alloys at 2640. Well, see, this is what this is right here. There it is. Between 2640 and 2800. In that range, in between there, gives you this. Iron-nickel. And these are the rare ones, they say. All right, well, let's just get started. I got stony meteorites. I've got the chondritic types ones, the chondrules. I have the iron style, stony iron maybe you'd call that, depends. It's very magnetic. And then I have this one here, which I show all the time. I just put a little tiny bit of water on there, and you can see how quickly it rehydrates into blood. I think you can see how red that is. I don't know. That's pretty red. And the reason it's so red still is because when this came through space, what happened was there was a plate that ran all across here. That was another layer, and it snapped right here because that's where the anchor is. And then we're going to look at the anchors too, because these are the anchors. We're going to look at that in a microscope. But when it did, it got so hot that that blood that was there, it was still wet, expanded and blew that layer right off. That's why it's still so extremely red. And you can see right at that little spot right there where it comes in. That little tab right there. That's where it locked itself in. And there's some black blood there. It does not mix with the red, and the red is just all over the place. And as soon as you put a little taste of water on it, it rehydrates. That's what the deal with the red blood. Red blood just stays forever red. You know, fluidy. And this one, the stony one, exploded because this was saturated with red blood too. This side was the artery side. This is the vein side. You see that little hole? You see that circle right there? That's where the vein was. And right up here is the other vein hole. And at the end would have been where the vein is. All right, and it's all through space and burnt up. And got so hot that the blood in here exploded. Now, I drilled that hole. I drilled that hole in there to get fresh red blood out of there, which you got to go deep inside. I don't take it off the surface. I don't think I drilled that one. Maybe I did. I don't know. I have to remember. But you can drill into these. It's just not a problem. See, it's simple. And this is a fingertip came through space. He's, oh, come on, Roger. Yes, it is. And I have one here on Earth that is identical. The hook, the two blood vessels, the veins, and here's the arteries on the other side, just like this one. No difference whatsoever. The two on this side and the one on the end. This one just exploded, so you don't see it, but this one just drained out. Now that was drained because it got squished flat. It obviously shouldn't be that flat. It's a fingertip. Somehow it was crushed flat, and it squished all the blood out. Now look at this. You see that little spot right there? Look at this. It's got the same spot. You see it? That's an anchor. Now you see this? You can't possibly believe that that's just accidentally perfectly round. And there's another accidentally perfectly round one here. And this one was where the artery was, and it exploded out. because there was wet blood in this when this came through space. It's out there, it's wet, and and I think they found water and everything in the Bennu sample. Now all of the little strappy parts of the tendons boiled off, and you can see where those little holes are. All right, and you see all blanched off, and that's because this came through space and got real hot, and where it still had red blood, which was this side, exploded out. Then I have this one, which is extremely, I would say probably the rarest meteorite that's ever been. That is extremely magnetic, and this is bone. This is the marrow from within a bone. And the bone part is not magnetic, but the marrow part is. And it's highly magnetic. It's not just a little bit magnetic. Now, I believe I showed you the temperatures you have to reach. Why did this bone remain bone? And this turned into just a nice, strong magnetic iron. The only thing I can say that I believe is this bone, this was the marrow inside, which is literally solid iron. It's blood, it's all bloody marrow. And that would have turned to iron, which it did. And the temperatures, you have to have the certain temperature to boil everything off and leave the metals. So we're going to go through some microscopic shots of all this, because it's very, very interesting. To me, it's very interesting. Some people, no big deal. But I want to show you well, let me just, hold on one second. All right, this is completely over the top shocker. You see that? That's a fingertip, and this was CAT scanned, DNA tested. It's a fingertip. You see that? That almost looks like it was cut off of this, and it is not. This one is cut off of this big piece up here. This one here. Now, mine was CAT scan. This one here was CAT scan, and this is just the cut and the look of it. Now, this is the look of the CAT scan, which would be just like I cut mine, but this is the 3D deep look into the inside of that fingertip. This, they just cut it across, so you can see it quite obviously. But what I want you to look at is this right here. Now just take your time, let your eyes focus in for a second. This is the dead center of this bone, and it's a bone. You got this right here, is the core of the bone. Now take your time, slow down. In addition to the core of the bone, you have a flare at the bottom, which is this piece. This is the difference between the core of the bone, which is this is the center, and then the flare of the bone. And when I say a core and a flare, it's exactly what it is. This one here creates its own little stem going up. This is basically the anchor spot at the bottom that holds it in place. Now take your time, look at it again. Look at these details. You see that? Let your eyes sink into this. You got to get at mud fossil eyes. You see this? You see that? Just follow it. This down here is, it looked like it could have been burnt off or what, I don't know. But my specimen looks almost identical to that in the CAT scan. Now, it's sideways, but you can see right here, if this was tipped this way, that's what you'd be looking at. You see the center? That's what I was talking about before. You see this ring here? That ring is the bottom part that really holds the fingertip in place. And then from that, it tapers up until you get to the apical tuft. And the apical tuft is up here at the very end of the fingertip. And all your little tendons anchor into there. But down here, at the very bottom, you have blood vessels coming in both sides, and you have tendons. And I'll show you that in the CAT scan as well. Hold on. All right, what you were just looking at in the 3D where you're inside is this. This is a 2D where we're going to surface scan from a million different angles and putting it together and making it into something quite easily to see. You see that? You see that little core right there? Take your time. You see that? That's a blood supply. And that is a tendon. That's why you can do this. And the blood makes it so that it has energy. Now, this is the other side of that finger. And that's the tendon, same as this on this side. And this is not the same color as this because you got the black and the red blood. Two different colors. Now, this is the bone. Right, that's the bone. And this is actually that fingertip. And at the very end, inside there, you have one of these, which is an apical tuft. So the big piece down here, which I showed you before, the big piece shows up at the bottom, and then it flares up to the apical tuft. And that's what holds all the tendons in. And this was DNA tested, so it's not something I'm making up. And as you can see, it's virtually the same thing as this. And this one has, like I said, that's the same thing, the central part of the bone and then the outer part of the bone, as I showed you in the CAT scan. All right, central part of the bone, outer edge of the bone. And then you got some big arteries going up in there, arteries and veins. Now, let me show you something that happened in this one right here. This shows it cut off. Here's what they did. They found this big, I'm saying it's a fingertip. Well, I can't be positive of that. I'd like to see what it's constructed of down on the other side and so forth, because this is the only side I've seen. This right here, take your time and look. That right there, and that little center, this is the bone. That's the bone. Now they cut off this spot here, which was the flare. This, I believe, was on top of there. I'm pretty sure. Now you see that hole right there? Why is that hole there? And what's going on with this one here? And why is this big round bone in the middle? And this is the tendon. And that's the other tendon. Now, I don't have good shots of this, but I'm saying these are two of the tendons, just like I showed you on mine. And these are the blood supply, which this has eroded off here and here, been burnt off coming through space, but it didn't get to the bone. It left the bone. But it burnt off this area here, and it probably exploded off because there was probably still blood in there. And the same thing here, it popped off. And you ended up with the bone, just the bone. And then the rest is the fingertip coming up. And this shows where this has smelted quite a bit. And the fingertips, like I said, they are saturated with blood. I mean, absolutely saturated. So that's where, and the blood smelts, and the blood contains the metals, and the metals are in the, wherever there's a lot of metals, like inside of lungs. A lot of metals, they turn into iron. Inside of liver. Heart. Excellent, excellent smelting, causing iron and metals. Okay, this is Roger once again. I made a whole bunch of statements and you've gone through all this, but the stony, the iron, and the stony iron meteorites are what we're going to be looking at in the microscope shortly. Okay, meat fell from the sky. The Kentucky meat shower, a bizarre event in 1876, chunks of meat fell from the sky in Bath County. The exact cause remains a mystery. No, it isn't. It was a body part exploded coming through space. The most common theory is that vultures, having overeaten, vomited mid-flight, and the meat was then scattered by wind. This one guy ate it. He said it tasted like elk. There's nothing but biology, and once it comes through, it can come through very, very wet. Okay, this is run pretty long, and people get upset when it goes long, so I'm going to cut it off here and do part 2. And that is the red blood coming out of this bone. And that's a bone. Alright, you see that? That's a bony material, and guess what? That red blood has turned black because it's been cooked and smelted out of the marrow of the bone. And that is highly magnetic, and you don't get that until you hit an extreme temperature. Now, why didn't that just cook off too? Why didn't that burn? It's because it came through the particles in space, which is the ionosphere, and it just overcooked, it just overheated. And cooked off all the cheap stuff in the blood, which is the fluidy stuff right there. You see that? Watch this. That particular spot is magnetic. The rest is not magnetic. Hold on. Throw a couple of little balls on there, you'll see. Oops. You see this? Magnetically, they're just being held on there because it's turned into iron. But down here, it won't hold because it's down here, it's still bone. You put it here, it just rolls right off. You can't get it to stay there. But down here, where it's the blood is boiled off. Now, you would expect both of those things to have been heavily reacted by this kind of temperature, but the white stuff, which is the bone, just kind of blanched off. It's almost like you took a little blowtorch and squirted it at that. But the blood here, that stuff really cooked. So I say that was marrow, and that's like some kind of big blood vessel or something right there. You see how round that is? So that's probably an artery. Well, I would say almost absolutely there's an artery right there feeding something, or from the bone marrow feeding out through that artery, something like that. But I'm almost certain that's an artery that has just smelted because it's red blood and it turns into iron. All right? That's about it for today. I'm going to just keep going with this until it starts to be understood, and we can start to see the world for what it is right around us. Because right now, you know, you just accept the words that are being told to you, and you really have to accept them and repeat them, or they will fail you in your life. That's not a good system. Mudfossil University is the place to be to learn the actual truth and then discuss it. It's okay to talk about mainstream. I have no problem with that. I know everything the mainstream has to say. I had to study every bit of it, 100%. And I found out, I'm not kidding you, I found literally nothing that was correct. I mean, I'm serious, literally nothing. So stay with me, and we're going to get into the microscope. We're going to get into all these little buggers, and stay with me. Stay with me. All right, I'll talk to you later. Love you all.